Then Brian, you can start presenting. So first of all, thanks everybody for joining us today for another session of the Data and AI Architecture Virtual Group. With us today is Brian Bønk out of, did I say your last name? Okay. Is it
That's
Bønk or
fine.
Bank?
That's fine.
Yeah, okay. So Brian is joining us from Denmark, and he's going to be getting us all into the Microsoft Fabric. This is a new product from Microsoft. It's currently in public preview. Tons of interest here. This is kind of like the child of Synapse. And yeah, we'll see how it's going to play out. So we're going to be covering today, especially the data warehouse in Fabric. We got some other good sessions coming up. If you look at the calendar, it's about one new session every 2 weeks, and we already have everything filled up until mid-December. Then we're going to take a holiday break, and we'll probably be back sometime in the second half of January. So really, really good stuff. Also, thank you everybody that has spread the word and shared about the group. We are closing in on 1,000 members very soon. I think we're almost up to like 975 or so. So it's going to be a good milestone. And without further ado, I'll just leave it to Brian. Brian, the stage is yours. I'm going to mute myself. Everybody, please keep yourself muted. If you do have a question and Brian is engaged into the question, feel free to unmute yourself then at that point. All right. And thanks again, Brian. And the floor is yours.
Thank you. Let me just start by sharing my screen. And I need to reopen Teams so I can see all the questions. That's fine. Well, first of all, thank you for having me. Thank you for inviting me, and I'm really thrilled to present to all of you. I see we are counting on 28 people right now, so that's fine. Just keep it coming. And as Warner just said, if you have any questions during this session, just please write them in the chat. I'll see if I can take a hold of them, and if I can't, Warner will just interrupt me, and that's quite fine. I like it that way. So keep it coming, and I'll happily answer any questions. As I said, my name is Brian. I'm from Denmark. I'm the principal architect of data and AI inside Fellowmind. Fellowmind is a European organization with around 3,000 employees. If you scan this QR code, you'll be directed directly to my LinkedIn profile. If you would like to hook up, I'll gladly expand my network there. I also have a blog, and you will find all the slides in a couple of days at my GitHub profile. I'm a Microsoft MVP on the data platform, a fast-tracked recognized solution architect on Power BI, and also a Microsoft certified trainer. So enough about me. Now let's get going. So actually, I just attended a conference in Germany. That there I met some people from Microsoft saying, try not to start all your sentences with so. So here goes. No, sorry. Fabric came out a few months ago and are now in public preview. Before Fabric, we had Synapse serverless. We also had Synapse dedicated pool. But in this session, I will try to not persuade you, but to tell you what the differences are, and perhaps also how to migrate from serverless to Fabric if you would like to do so, focused on the data warehouse platform. So I did it again. So serverless and the Fabric warehouse is still based on the Polaris distributed SQL query engine. If you don't know what that is, then I have a couple of slides on it. I will not go into deep detail about it. I'll have a few links about where you can read more. A very, very deep technical white paper on the Polaris engine, and also a translated blog lookalike read where you can read about the Polaris engine. But let's just dive in a small bit into the Polaris engine. There you will also see how things are happening inside the Fabric and the Synapse universe, and also how to perhaps leverage the performance out of there. The Polaris engine is based on the right column on this picture. The left column is the standard SQL Server you have on premise or in Azure, where you have both caches, metadata, and data in one engine. You have your LDF files and your MDF files and all these other supplement files underneath your engine. On the right side of these columns, you have the the data, metadata, and your compute separated. It is also called stateless compute because the data is just stored in either a data lake or a OneLake if you are in Fabric. It is just lying there. No one is touching it unless you are querying it or manipulating it in some way. And then you have the compute engine on top that handles all your select statements, your data manipulation, and so forth. But how does the Polaris engine actually store the data in the OneLake at the stateless approach? Well, here we have a data chunk, a chunk of data that this could be anything. It could be one file, several tables, a view, or a store procedure, or something. When you as a user are storing your data, perhaps you are also implementing some partitioning. Perhaps you're partitioning on year, month. That is the most typical. I've also seen implementations on organizational level because the organization is so big, so it makes sense to partition on the organization level on a high level scale. Once you do that, the Polaris engine is accepting your files, your parquet files, and are also implementing its own hash distribution of those files. So your files are the rows, and the hash distribution are the columns in this picture, not true compared to rows and columns in a table. All of these boxes are called cells in the Polaris engine, and one or more cells can be one object. In this example, I have just marked 4 cells. This could be one table, one object in your Polaris engine stored in your OneLake or storage account. Once you begin to query it, these cells are being loaded in from your storage account, either ADLS, Cosmos DB, or OneLake. OneLake is still just ADLS with some sparkle on top of it. And now it is called a data set. And now it is also forwarded to the distributed query processing, the Polaris engine. How is this done? Well, I'm going to introduce you to 2 new words in the SQL world. One is called a task. A task is one single process that needs to be done. And then I have a DAG, a direct acyclic graph. This is math, but a task is one process that needs to be calculated. And a direct acyclic graph is a group of tasks that needs to be done. Why do we have a DAG? Well, because a task can be as small as it can be, so it can be grouped together into one DAG and then handed over to the processing engine, and the select statement can return data back to you. All of this is done without you even having to think about how do I parallelize my queries, how do I engage my query engine, how do I distribute it, and all this stuff. These are done for you by the Polaris engine. The Polaris engine is also used in Fabric. In this example, I'm using the Fabric. We have OneLake on your right side, on my right side, and then on your left side we have the actual UI where you are typing in all your select statements. You are connecting to the front end, the SQL front end, and the SQL front end is then connected to the distributed query processing. The distributed query processing is handling all the distribution of your parallel processing and are asking for the backend SQL pools to handle your data. Once that data is read out from the OneLake or written to OneLake, sorry, once it is read from OneLake, it is directed directly through the data channel to the SQL frontend and presented to you as a user. I don't hope I lost a lot of you here, but this was an introduction to how the Polaris engine works. If you would like to read more, there are the white paper here of the Polaris engine. I can see I made a type error, but that's fine. And if you would like to read it in a blog post, I have it also here, and the links will be clickable once you get the PDF on the GitHub place. So let's move on the comparison between serverless and the warehouse. The serverless is using the ADLS as the storage account, as the storage engine, as the warehouse is using OneLake. OneLake is still just an ADLS with some sprinkles on top. I'll get back to that later when we hit the demo. The storage types, storage formats here is the serverless. Perhaps you already noted. You can store it in Avro, Parquet, CSV, and all these stuff. Whereas in the OneLake, you are forced into Delta Parquet files, or if you twist it a lot, you can also store it as CSV files. But the Delta Parquet files is the default thing to do, and it is also where you get the most performance SQL queries out of the box. With serverless, you had the possibility to do the data query language. You could also do data definition language if you made a CTAS, an external table that read data out of your storage account. And those were the things that you could do in serverless. With the introduction of the warehouse in Fabric, you also now have the possibility to do direct DDL, data definition language, create objects, data manipulation language, update, insert, all this stuff, and of course the data query language. The support for the T-SQL is on the serverless almost full. There are some limitations on the serverless. One of them is you cannot do recursive CTEs because that requires a storage account in a temp table, and you don't have a temp table in serverless, so you cannot do that there. In the OneLake, you will be in the future able to do the full set of T-SQL support with also the recursive CTEs. So how does this Fabric engine actually works when I try to load data into the warehouse? We know now that it is using the Polaris engine. It is storing data in the OneLake as a Delta Parquet file, and I will now be able to do SQL queries on top of it. But the first three things are important now because I have tried to load in a big chunk of data to the warehouse to figure out how fast is this to adopt my data. I took the Open Data Storage, which is a public available to everyone in the world, that within other data sets also stores the New York City taxi data set and is updated every month. So if you need the New York City taxi data for anything, you can find it at the opendatastorage.blog.core.windows.net. You can log on with Anonymous, and then you're good to go. I copied everything from this storage account on the New York City taxi data. It is somewhere around 1.5 billion rows. Once I did it, I just used a classical copy activity within the new Fabric pipelines, and I moved around 86 megabytes per second. Is that fast? Is that slow? Well, I don't know. It is faster than the Synapse engine. And I also know that after I did this, there is now a possibility to remove the staging from the destination before the warehouse, so that might speed up things. But in my opinion, to load 1.5 billion rows, 50 gigabytes in 10 minutes, is that fine? Yes. If it was a data warehouse loading by the night, it's fine by me. 10 minutes to ingest 50 gigabytes, that's fine. So these are just comparisons or to show you how much data you can push in or squeeze through the warehouse. So over to the demo. If I can find it here, just bear with me. I have it here. I'll drag it in. There you go. For the purpose of this demo, I created a workspace with Fabric enabled, and I have created a warehouse and a lakehouse. The lakehouse is only to be used for demo purposes to ingest data. Once I create a warehouse, I get two objects. I get a default data set out of the warehouse, and I also get access to the warehouse. If I click the warehouse, I hope this loads because there you go. If I click the warehouse, I'm instantly, not instantly, but I should be moved into my overview of my schemas and my tables and my views and my functions. For now, I don't have anything because I need to load data into the warehouse. These are stored. The data is stored in the lakehouse. The Lakehouse contains right now of 3 tables, which I have uploaded through my OneLake Windows application. Let me see if I can find it. It should be here. And I just need to move this down a bit. There you go. Can I zoom here? No, I can't. If I do this, can you then see it zoomed now? Corner?
Yeah, it looks pretty good. No,
Okay,
it looks
great,
pretty
good. This is the installation of the preview feature of the Windows application, where I can now begin to browse my data in the OneLake. Once you install that, you log into your tenant, and then you are presented with all of your workspaces. These are my workspaces that I have access to, and this is the workspace we are using today, the architecture group. If I drill down to this, I now see that I have a lakehouse. Oops, sorry. Let me try that again. I have a lakehouse and I have a warehouse. The lakehouse consists of a folder structure, and if I go into my files, I can now see that I have the exact same files, customers, orders, and products, as I have in my lakehouse. Customers, orders, products. If I would like to upload another one, then in my files, I can click the 3 buttons and then click upload. I can either choose upload files or upload a folder. But once I have the data, once I have the OneLake application in Windows installed, I can just use my file explorer to do this. So if I would like to have my employees loaded over, these are my employees' data. I will now copy it, and in the files, I'll paste it. This just needs to sync, and now I have all 4 tables uploaded from my Windows account directly through File Explorer to my OneLake, to my Lakehouse. If I go back here and I refresh it, I now also have the employees table here. In order for a CSV file to be transferred into a parquet file, I can right-click the 3 buttons, load to tables, to a new table. I'll just call it employees for the sake of this, and it will start loading the employees CSV file into a parquet table in the OneLake. While this is running, I'll just show you what is happening in the parquet file world of the Lakehouse. Again, inside my files, inside my File Explorer, I also have a folder called Tables. If I open this one, you can see that I have the 3 tables that are already loaded before this demo: the customers, the orders, and the products. If I open this, well, if you are used to working with Synapse, you will by just an blink of the eye identify these as a parquet file. That's fine. And within the parquet file folder, I also have the delta log, and the delta log contains the JSON object that tells the engine which tables to use where. Sorry, which file to use where. If I refresh, I should be able to. This is still in preview, so sometimes it works, sometimes it doesn't. But once the OneLake application syncs to my Fabric workspace, it will also show a 4th folder down here named employees. Let's see if this loaded. There it does. Now I have all my 4 tables as parquet tables in my Lakehouse. But how do I get this to the warehouse? Well, the warehouse is just a database on a server, so I can, if I like, do a select statement from the employees that I just created from the Lakehouse. I named the Lakehouse for ease of use here. If I can move this out of the way, I can't. But here you can see I have a select statement on the employees, and I can do the same thing on. Can I do a control R here? No, I can't. Then it'll just reload. Thank you. Back to the demo. I can do the same thing with products, orders, and customers. This is a very, very simple data model. If I would like to load my data to my warehouse, I have now the possibility to, of course, create a schema. And this is if you ever have created a CTAS on the Synapse serverless side, then you will more or less look or recognize this context, because I can now create a table called customers, which is based out of the Lakehouse Delta table that I just loaded from the customers. I can do a select statement directly on the customers, and I can see the data. It's here. And I can also create a table based out of this data. This will just load. There you go. And if I then refresh here, I have a data warehouse, I have a tables, and refresh this one. There you have it. Now I have the customers data loaded from my Lakehouse. It could be anywhere in the world, but from the Lakehouse, I now have my customers data, and I can begin to browse my data as I would any other SQL Server. As you saw, I had a lot of tables here, so let me just start this one. Run. Oh, I did a typo somewhere. Was it full name? Line 72? I don't have a line 72. That's typo. That's the demo monster is there. There you go. Name. There. Sorry for that. Let me just load the rest of the tables. Now, while this is loading, let me show you what is actually happening behind the scenes in a Fabric world. Here I have my Azure Data Studio. I've made a notebook to show you what is actually happening behind the scenes once I create objects and servers and services inside the Fabric universe. So I need to select this to change my connection to the connection string of this copy. This is a SQL Server. I'm using MFA. I'll just this, and then I'll connect to it. There. Now I'm connected to my Fabric data warehouse, or my Fabric server, actually. If I do a select at that version directly on top of my server, I get this result. This result is the exact same SQL Server build as I would get from the serverless SQL pool from a Azure SQL database or Azure SQL Server. The exact same build, the exact same service level. So it is quite recognizable. I can also see here, if I use my master database, that no matter if I create a warehouse or a lakehouse, it is just a database stored in my server. There's nothing new under the hood here. The lakehouse is a lakehouse, the warehouse is a warehouse. That's fine. I've just named it these ways so we know which one is what. A bit to the right here, I have this collation. This collation might disrupt some of you because this collation enforces you to be case sensitive once you write your SQL queries. This collation you cannot change as we speak. Perhaps that will change later. But this collation enforces the UTF-8, and it also enforces the case sensitive query language. So if I write, you just saw the typo of the capital A, I need to write that in small letters, or else it will not compute. All the other informations to the right are standardized information based out of the SQL Server. But what about the server properties? What edition and version am I having? Well, as we saw before, I have the version 12 and the edition of the SQL Azure. This is the same thing as if I would create a server inside Azure. And the engine edition is 11. If you don't know what the engine edition 11 is, it is the same version that was underneath the serverless engine. And here they have now made some small tweaks and enabled us to do data manipulation language on the engine. But what about the recovery model? Once, if I had done this on a serverless, I would get recovery model of full. I still get that. Well, this has been changed in the last couple of days. If I had run this like 2 days ago, these recovery models would have been simple, but now they are full. And I can't get my head around why they keep returning back to full recovery model, because I have my engine is just an engine. It is only being used for compute. I don't need to restore transaction. I don't need to restore any other things than making sure that my queries are running. And if I have a simple recovery model, I'll still have the asset properties. So this breaks my brain on why they are returning back to full recovery model. What about the files and the locations? If you have been so lucky as to be a part of the preview on Fabric before it was named Fabric, you would also know that it was named. See, they have moved it here. They have changed it, perhaps. Have they changed it? Yes, they have. They have changed it here, but this was to show you that that it is still just the data files underneath are still existing, even though we're not using them. And we have, of course, a row file and we have a log file. But what about the physical names? Where are my files stored? There you go. You see it. I still have an LDF and an MDF file, even though I'm not using them. But look at this. Look at this. Trident. Trident is actually the working title of Fabric before it was announced. It was called Project Trident, and we still see some residue of the Trident name around the service. And once you start working with the Fabric service, you will also see error messages where it says Trident somewhere. So Trident is still a part of the product name. But what about TempDB? Do we have a TempDB? In serverless SQL pool, we had a TempDB because we need to handle the data processing inside a TempDB. We had 4 TempDBs, and by near coincidence, I think not, but we still have a TempDB with 4 data files, and of course 1 log, and these are again stored inside the Trident folder. Look at the sizes here. The size are 2 gigabytes. So I have a total ability to process 8 gigabytes in a TempDB at a time. This could mean to me that I need to be aware of how many data I'm pulling through the warehouse engine, because I'm only allowed 8 gigabytes of TempDB data to be managed. So just take care when you handle it. I need to capitalize this one. Whoops, sorry. But the information schema is also available. If I go back to my warehouse and collapse this, then this view is showing me the constellations of objects in a schema grouping, and I can now see that inside the information schema I have it looks like that I can access the standardized views on the information schema. But what happens if I just do a select star from the information schema.tables? I get this error. Sorry. Invalid object name information schema.tables. It is not invalid. I know it is there because I can find it here. There, it is right there. Right here I have it. Information schema.tables. It is there. It is a view. I can see it. It is there, but I do not have the privilege to do a select statement. I think this means that we are sharing the servers between workspaces. If I could do a select information schema.tables, I would also perhaps be able to see other table names inside the same server. So that's fine, but I do have access to sys.objects. So that's great. So I can still do my metadata discovery on my server. And a funny thing is, if I can find it, let's see if I can find it. There. Let me just make this a little bit broader. Sorry for that. There we go. We can see what's happening. There you go. And then scroll down there. Look at this. SQL agent. There are still tables named SQL agent job, job steps history, and job step logs. So it would be funny for me if I could hack this and then do a create SQL agent job statement and then have things running automatically from my warehouse. Unfortunately, this is not an option. So we have to wait for other things to work. But we still have access to all other sys informations that I can do normal select statements on. So that's fine. Oh, I need to capitalize this also. What if I were to create a table? In the warehouse, I would just create a table called dbo.customer. If it is there, I'll drop it. No, if it is not there, I'll create it. If I run this, I'll get an error. This is one of the also annoying things about this collation that I'm enforced to use. I cannot use in varchar data types, so I need to use varchar, and then I'm good to go. Once I have created my table, I was told from Microsoft that I have a full data manipulation language feature set, but I'm not allowed to do a truncate. Truncate table is not supported statement type as we speak. It will be implemented later. So if you have to delete your entire table, you have to make an ordinary delete from table statement. Even though this table is empty, it will still run for quite some seconds until it comes back to me saying, now it's empty, 0 rows affected. So that's fine. I hope I am done with the data load now. It is done. Oh, it took only 8 seconds. So now I have loaded all my 4 tables, my customers, my employees, my orders, and my products to my warehouse. I could, if I would, I could make this more complex doing on my orders. I could do lookups on my business keys to find my data warehouse keys and all these stuff. I could do this in my select statement, and I could also implement this as a store procedure if I would like to do that. But now I have my data here, oh, I lost it. Sorry. No, yeah. But what if the employees table were actually in another place in the organization, in another Fabric warehouse, in another lake house, in another workspace? So if I drop table data warehouse.employees on this, now that has been dropped and it should be gone from here. There you go. And back to the lakehouse. Just to clean everything up, I will delete it from here. And also in the files, I will delete this file. Now it is gone completely from my workspace. And I actually have this new functionality of a shortcut. What is a shortcut? A shortcut is, as it says, just a pointer to where the data is stored. And then when I need it, I can begin to read it. I'm not moving any data until I start doing my select statements. I have an option to, of course, use an internal OneLake Fabric approach, or I can connect to my Azure Data Lake in another resource group, and also the Amazon S3. Be aware that in Amazon S3 you have to pay for the transactional cost on the read. So, but here I will now be presented with all the objects that I have access to. And if I select the warehouse, the Lakehouse 2, where is it? There you go. If I select the Lakehouse 2, click next, into tables, I will find my employees, which I just deleted. I can mark it here, and I can see this is also loaded as a parquet file. I can create it. Now I have an employee table mapped from a shortcut. This shortcut could be anywhere in the world. It could be from your client. It could be from another warehouse. It could be you are presenting a table to a client outside of this, outside of your organization, and they could use the shortcut. Don't be scared that sometimes it comes back unidentified. I just need to refresh it, and it should be good to go. There you go. The employees are now there. I need to zoom here to show you that the small icon on top here shows a link from a chain, which shows you this is an external table that is reading data from outside your Fabric warehouse, your Fabric workspace, but I can still select the data as I would any other data. And
I have a question for you, Brian, regarding
sure.
this the shortcut bit. What's the unit for a shortcut? Is it a table, or could you shortcut a bunch of tables? Could you shortcut a whole database?
I can only shortcut objects, so that would be a table or a view.
Okay, so if I had, let's say, one schema with 100 tables, with today's implementation, you would have to have 100 shortcuts to share the whole thing.
Let's try it out.
I'm just wondering, like, what's the granularity of a shortcut?
You see, once I get through my visual guide on selecting my objects, I can only select on an object level. I cannot select all the tables.
Can you
I
select
only have
a bunch of those?
Sorry?
Can you select a bunch of those?
Yeah, sure. I can select vendors, subcategories, categories, and so forth.
Ah, I see, but it's not multiple selection. It's just one at a time.
It's one at a time. Yeah.
Okay, cool.
I hope that this will be programmatically enabled, so I can do this by script. But for now, we need to go through this wizard. So
cool.
Yes. So now I have my employees table in my lakehouse, and in my warehouse, this is not the correct warehouse. Yes, there you go. And in the demo script, I can now recreate my employees table. There you go. Now I'm reading the data from a arbitrary workspace, still inside the space that I have access to, and I'm now creating a table based out of that. And the tables here are now, come on, all four of them are back. With the warehouse and with all these tables, as I just showed you, I also get a default dataset. This default dataset contains all my objects that I have in my warehouse, and you can see the data model if I click at the bottom here, right down here. I have 4 sections. I have my data, I have my query, and I have my model. Oh, I forgot something. Let me show you this query. There's a new functionality. Perhaps it is not new, but it is somewhat tried to be re-implemented. And Juan and I just discussed this before we started, that there's a new possibility to do a visual query. A visual query is, if you don't like to write SQL statements, you can do a drag and drop. If you have played with the Power BI data marts, you will recognize this look and feel. It is a copy of the data mart functionality. Now I have the possibility to do views based on a click with a mouse and do transformations. I can do sorting. I can reduce groups. I can combine. I can do stuff with this data as I would see fit, and then I can save it as a query. I don't know if I like this. This is pulling me back to the right click a view and then say edit, and then I got this gigantic picture of joins and tables. I don't know if I like this. If you like it, then please go ahead and use it. It is doing the exact same thing. It is translating what you're doing here visually into a SQL script. So that's fine. So back to the model. The model is, if I remove this, if you have ever been in Power BI, you will recognize this at an instance. And I have my orders. I have my customer. I have this. Oh, sorry, I don't need this. This customer table is the bogus one that I just created. So I'll hide that in report view, and right out here I have my products. So now I can start to build my star schema, and it is just a matter of drag and drop. From customers to orders, this is a one-to-many. and I'd like to make this relationship active. And for the demo purposes, I'll just assume that there is a reference, there is integrity between the columns. And the same thing I will do with employees, employee ID to employee ID. It is a one-to-many, single, active, integrity, and the products, product ID to product ID. One-to-many, single, active, integrity. So now I have a beautiful star schema. I can model my data as I would see fit. And I also have the possibility to, once I mark a table or an object, I can create a measure. This measure is standardized DAX, so I could say sum of freight equals sum of orders. Oh, sum of freight equals the sum of orders dot freight. Oh, a small thing that they actually did is, I think it was last week, they started to mark unclosed parentheses with red, so you know that you have unclosed parentheses. So here I have one unclosed, and once I close it, it becomes blue, and it is marking what the parentheses are closing. I like this feature, so now I can, with a blink of an eye, see what parentheses are not closed and don't get an error. So into that.
There's a quick question here on the chat. Just
sure.
It just says, what's cross filter direction or cross direction filter or
the cross filter direction?
Cross filter direction, yeah.
Yeah. The cross filter direction means that if I would like to, I could also filter my orders and then have the products table filtered. It is just a representation of this arrow. In what way can I filter my data? Here I can filter my orders table based on products, but I cannot filter my orders. I cannot filter my products table based on orders. If I choose both, then I have the possibility to go on. There you go. I have the possibility to filter my products table based off what I selected in my orders table. In a star schema, that perhaps doesn't make sense. It will make sense if I have a many-to-many relationship, and I need to filter my fact table based on another factor's fact table. Then I would need this type of connectivity. You will also see that a single filter direction will boost performance quite. I'll just skip this bad validation. A single filter direction will give you a better performance. So that's fine. I hope that answers your question. Good, thank you. Now I have my star schema, and I could now begin to build a report. New report. There's a button for that. What is happening now is that Fabric is now building a Power BI report that automatically connects to my data model, and this, and I can begin to draw in. Here I have my my calculation, sum of freight, and I can begin to do that by customers. Customer, I don't know, product name. There you go. This could be my report, and it is just a matter of dragging and dropping, and then I can begin to do stuff with it. I could filter this by last name. Perhaps I wouldn't place a filter here, but need to drop. Thank you. Oh, sure. Here, and then I can begin to filter my report based out of this. Please note that once I'm doing this, once I'm clicking the Create Report button here, I'm directed here, and the connection on the where is it? Why is this gone? It is gone. Perhaps I can see it here in the properties. It has moved there. In the advanced part of this, I will see that the storage mode is direct query by default. Why is this? Well, let me zoom in. There, the storage mode is direct query. There are three storage modes. We have the import mode, which imports data into a data model, the old-fashioned way. Then we have direct query, which is this one, which reads the data directly from the SQL Server. And then we have a mix of them called both. And then we have a new one called Direct Lake. The Direct Lake storage mode is only available once you read your data out of your lakehouse. But it is the default storage mode in Direct Query when you're using the warehouse, and Direct Lake when you're using the lakehouse. The Direct Lake seems to be a bit faster. I've done this on a very, very large data model with 1.5 billion rows. And I saw a performance gain of around a second or something when I used the Direct Lake compared to the Direct Query. But on 1.5 billion rows, I think that is okay to wait a second. But it's up to you to decide what to use here. Back to the model, and I can now save this model. I can save it as architecture group. Save. And now it is ready for distribution to users. They can filter whatever they need and start using the report. So now I'm actually up and running with a report from my data source. It could both be a link, a shortcut, and also raw files. I could, of course, also load these tables or objects from a pipeline. But what about gigantic amounts of data? I have one here. Oh, sorry. Screen flicker. I need to select a connection, and it must be this one. This is another warehouse, a different warehouse than in the demo. And just for the sake of it, I'm cleaning out the cache for any other queries that has been there. So I'm on an empty cache with no cached files. I think this will return around 1.5 billion rows. It will take quite a few seconds. And yeah, there you go, 1.5 billion rows. Quite a few records here. And I can now begin to do my query selections. Here I'm grouping by vendor ID. These are just to show you that I can do whatever I want in my warehouse. I could do filtering, I do group by, I can do order by, and I get quite a decent performance. Let's take a note of these. This is 3 seconds. This is 9 seconds. And the more detailed I become in my query statements, the longer it will take. But, oops, sorry. 10 seconds. And of course, I can also do window functions if I would like. It only takes a second. But look at this. What happened here? I went from 10 seconds to 1 second. What happens if I run the same thing again up here? Now it only takes not even a second. And if I run this again, this took 7 seconds. Now it takes 1 second. What's happening? Oops, sorry. Well, the thing is that the Polaris engine is only using one node per default. It is shutting down all the unused nodes. Once you begin to query using your Polaris engine, the engine will begin to ask for resources. I need resources. I have a geek, an idiot, trying to do select statements on 1.5 billion rows. Give me resources. It takes a few seconds for those resources to be allocated to the connection, but once they are there, my performance will begin to improve significantly. This took 10 seconds just before, and now it only takes 7 seconds. So things are starting to improving the more I use the engine. This could mean that I need to warm up my engine before I start my data warehouse loading. I could warm up the engine just by doing a cryptic select statements that does a lot of computing and then draws in all the computes that I need, and then I can start to do my data warehouse loading. Microsoft is aware of this, and they are trying to come around it in some way. I don't know how, but they are trying to come around it. This is just for information. If you need huge amounts of workloads on your warehouse, you can gain some performance by warming up the engine before you actually use it. I can't figure out when the resources are released again. I have tried to wait 2 hours, then they are released. I've also tried to wait an hour, then they weren't released. So perhaps it's between 1 and 2 hours, but I can't find the documentation for it. So it can also be, perhaps I was just lucky and someone else is unlucky and they are released within 15 minutes. But it's up to you to figure that one out. It is still undocumented. Quite a demo. Back to the slides. What happens if I have a current setup of an on-premise SQL data warehouse that I would like to migrate to the Fabric warehouse? You have some options here. One of them is the SSIS packages. If you have those, you need to rewrite them to data pipelines. It is the same thing if you have no, I'll come back to that. The stored procedures can be stored procedures. Stored procedures are supported in the warehouse part of Fabric, not in the Lakehouse, but the warehouse part of Fabric. And of course, SQL views is just SQL views. That's fine. What if I have a Synapse serverless that I would like to migrate to the Fabric warehouse? Here's a catch. Data pipeline becomes data pipelines. But as the data pipelines in Fabric are a completely rewritten engine, you cannot migrate from Azure Data Factory or Synapse pipelines to Fabric pipelines. There is right now, as we speak, no option to migrate existing pipelines to the new Fabric pipelines. You have to rewrite them. There's actually not even an option to import a JSON object to declare the pipelines and then just do a remapping. You need to do this on a clean sheet. The SQL view becomes SQL view. And if you have notebooks, you can also use notebooks inside Fabric and then connect to the SQL Server, do your manipulation, and then store data back to your SQL Server. This could be an architecture blueprint. You have sources on your left. You use different kind of connectivity to source those data into your warehouse. You can build your warehouse based on the medallion architecture, bronze, silver, gold, or whatever needs you have, and then use stored procedures to do that. If you need to draw in data from your clients or from other places, you can do that. Can I do this? Yes, I can. You can do that by using the shortcuts or just a SQL Server endpoint. The SQL Server endpoint was the one I copied from the warehouse, and then people can connect to that and begin to do select statements. I showed you how to build the dataset and also how to build a report. So during this demo, I have showed you more or less what is on this and what is on this architecture blueprint, and it is quite a simple architecture if you compare it to a Synapse architecture. Enough about that. What about the scaling? I just discussed this before we started with Warner, and these are the prices. If you have a trial, then you are on the F64, and you are given this trial 60 days after GA. When GA is, it is not yet announced, but I hope it will be soon. I don't know. And once you need to pay for this, perhaps you will downscale a bit from the F64 because it costs nearly $8,500 a month as pay as you go. If you have a reserve capacity, Microsoft tells us that the prices will be a lot lower, just around the P1 price, around $5,000 US. If you are to start on this without a trial, I would start around the F4, F8, and then see if that is enough. If it's not enough, scale up. If it is too much, scale down. Out of the box in Fabric, you get usage reports, so you can see how much compute you're using, and then go from there.
But these F levels, so one question, Brian. So these F levels, the people that are familiar with Synapse, especially for the dedicated pool, you could run a a dedicated pool, let's say a DW 300 or something like that, and you could know exactly how many nodes were behind the scenes.
Yes.
Right? Do these 2, 4, 8, 16s, what do these represent? Are those cores? Is that memory? Is that nothing? It's just like
it is capacity unit, and one capacity unit is the same as 4 vCores.
4 vCores.
More or less.
Okay.
4 vCores. Right. So this is actually like buying a new desktop PC and asking for vCores.
Okay.
And I have a question in the chat. What is the largest source file that you've processed? Wow. The largest file I've processed is 1.5 billion rows, and that fills up. In a CSV file, it fills up, I think it's 150 gigabytes. So it is possible. I haven't seen any limitations on the file size in the raw file size, but you cannot choose the file size once it hits the engine and are stored in the OneLake. It is completely handled by the engine, and I haven't seen any file size limitations here. It is only a matter of how long the pipeline or the process will execute. It took almost 21 hours to extract 10 gigabyte file. Is that normal? No, that wouldn't be normal. As I just showed you on the first couple of slides, I could process around 50 gigabytes in 10 minutes. So this is not normal. It looks like that the output from the storage where the 10 gig file was stored were not good enough, but I can't answer for it. But 21 hours is not
yeah, that sounds like
normal.
a lot.
Yeah, it's not normal. It should be around 2 or 3 minutes if it is a raw CSV file, and then there are all the other options. So good questions, keep them coming. I only have 1 minute left, and I will use that minute to once again. Oops. Where am my mouse? There you go. Sorry for that. To just show you this. Thank you for listening. Thank you for the questions, and thank you for attending. I really appreciate it. And I think we saw a number of 38 attendees, but that's great.
We had into the a little bit over 40 at some point. Yeah.
Great.
So pretty good. It was in Fabric Data Lake using ADF max throughput.
It was in Fabric Data Lake using Azure Data Factory. Oh, okay. So you're using an outside service to process data into the Fabric universe. Then you have the bottleneck there, because the Fabric universe is a closed circle. It is a closed service. It is a full SaaS service. So it needs the input, and it is on completely different servers and in Azure, and the throughput is not as good as if you had done it in a pipeline inside Fabric. So that might be one of the cases.
Okay, well, I think we're at the top of the hour. I want to thank Brian for the session today. I'm going to stop the recording now. Somebody's asking, where can the presentation be accessed later? In the description for the meetup, there's the link to the YouTube. I will be uploading to the YouTube in the next 48 hours or so. I'm going to stop the recording
and I will also upload the slides to my GitHub, and you can find it in the public folder. There are all my presentations from this year. So